All right. Can everybody mute? And I also wanted to mention before we get going, I wanted to mention that Xander will be doing roughly a half an hour presentation, and then Terry will be doing a presentation, a shorter one than we normally have. All right. I'm excited to introduce Xander. I met him many years ago when photographing his school, and then much later again when I photographed his family portrait. And I cannot remember how we started talking about astrophotography, and until a few weeks ago had no idea what that word meant. But hearing him speak about his work, I knew it was going to be amazing. And my hunch was right when I had my sneak peek yesterday. I'm very excited to announce our youngest presenter ever, Xander.
Hi, I'm Xander, and I've been doing this. I've been taking these photos for just under a year now, and so I'm gonna start my slideshow. So here we go. This is um, digital astrophotography, meaning taking photos of stuff in the sky with a digital telescope called the Seastar S50. So to open, this is the Sea Star. It is not what a conventional telescope you might think would look like. And so all of this here, this is just what you get. It's a full package. All you need is a mobile device in order to operate it, and it has all the functionality you would need. It takes the photos for you. It finds the object for you. It comes included with a stand, and it comes included with a solar filter, which we can showcase later. And so I got this about a year ago after I got interested in astrophotography by after taking my science class. I was starting to think about like the sky more and like seeing how like all this stuff in the sky is really cool. And so I kind of got into that stuff. And actually, the thing that got me into astrophotography and this telescope specifically um, was YouTube and the internet. It's actually like a great resource to find all sorts of things that you wouldn't think you would find. And so a video about this telescope just came up on my YouTube feed, and that's how I first discovered it. So the first thing I did when I got it is something that you can see quite clearly in the telescope is the moon. Fits very well into the like range of the telescope. So this is a photo of the moon at about half phase. And so I love the detail that you get with this. Like over here, you can see some very nice craters. And so after the moon, I thought, well, you can always see the different phases of the moon. And so I thought it would be interesting to make a collage of all the phases of the moon, taking a photo every day for a month. And so, with a few minor exceptions, this is a collage that I did of taking a photo of the moon every single day for a month. And so every day when I got home from school after I, did all my stuff, I would go out at like 8 or 9 o'clock and take a photo of the moon. And so I have this cool collage. So each of these is a photo from a different day. Then, also included with the telescope is a solar filter. So you can just take the little solar filter, here it is here, is you just put it on the telescope, you just pop it on the front of it, and then it can look at the sun without damaging the telescope and take these photos. And so the sun appears orange in the filter, and there are also these dark sunspots, which are caused by regions of the sun that are cooler than the rest of the sun, and though they're really hot still in reality, because of the solar filter dimming out so much of the light, they appear dark. So like these are different photos of the sun from different times, and so sunspots kind of like move across the sun and change throughout time. So then I kind of went on a spree, and these images I've kind of collected over the past like year. Some of these were pretty recent, some of these I took pretty early on. this is pretty much a full collection of every planet in the solar system. So we have Mercury, and then Venus. And a really cool thing about this photo is that it appears as a crescent because Venus is closer to the sun than Earth. And so when it gets to its brightest, when it's closest to Earth, it actually appears as a slim crescent similar to a phase of the moon. And so I have that photo there, and it's amazing that this little tiny telescope can take this photo, like, and actually see the curve of Venus. And then here's Mars. And Jupiter, what's really cool about Jupiter is that you can see, if you look closely, the bands of color on Jupiter. And something that's cool with also Jupiter and Saturn is that you can also see some of their moons. So these little dots are actually moons that are orbiting Jupiter. Same with these here orbiting Saturn. And Saturn is especially cool because, you can see Saturn's rings, and then Uranus and Neptune. And also a really cool image of a comet that passed by late last year, earlier this year, something like that. And so then these here are nebulas. Specifically, these are some of the brightest nebulas in the night sky. They're planetary nebulas, which are caused by a star similar to our sun. At the end of its life, its outer layers of gas kind of float off into space when it becomes a white dwarf and creates these beautiful, like super colorful planetary nebula. And so they're really bright in the sky. And, like for some of these, like for this one, for example, this is about maybe like 4 or 5 minutes of exposure on this. And so the way these photos are taken is by you point the telescope at it, and you can't just take one photo. You have to take a lot of photos or rather, you have to take a bunch of long exposure photos. How this telescope works is that you can actually change the settings from taking 10-second long exposures to 20-second to 30-second long exposures, I think, or maybe it's 10 to 15 to 20. But you take a bunch of long exposures and then you stack them together to bring out detail in the image that you wouldn't be able to see in just one exposure. And so these nebulas are, this one is the Dumbbell Nebula, this one is the Ring Nebula, and this one is the Helix Nebula. I know the names of most of these nebulas off the top of my head, because I've, one, photographed them a lot, and two, they're like a lot, most of the things that you can see with this telescope are like fairly well known in the astronomical community. And so these are some non-planetary nebulas that are actually just like huge, immense, vast collections of space dust that are being illuminated by the stars around them. Like this one is really pretty, and this one is called the Eagle Nebula. This one, nebulas have strange names sometimes, and objects in general. So for some reason, this nebula is called the Wizard Nebula, and this one the Trifid Nebula. And so this one is really pretty because you have this like blue dust right next to the red center. And so here's, more nebulas. So these are like some of my best images of nebulas. This here is definitely one of my best images of the Orion Nebula, which is the closest nebula to Earth. And this is the Pleiades Nebula. We will focus on those in a bit. But first, the bottom of a really large nebula in the sky that spans, it doesn't even fit in the frame of the sea star. This is just the bottom like leg of it, but it's something like, I don't know if I'd estimate like 4 times the size of the full moon in the sky. Like if you could see it like with your naked eye, it would appear 4 times the size of the full moon. This is the Crescent Nebula and the Lagoon Nebula. This one's really cool, is the Horsehead Nebula, because it has this like dark outline that looks like a horse's head. And this one is the Bubble Nebula because, there's like a little bubble there, which is actually really cool looking. And so then here, this is a close-up of the Orion Nebula. And so this is the closest and brightest nebula to Earth. And so something cool about this one is that, like the next one, the core, this really bright core of the nebula is so bright that you can actually see it with your naked eye without any aided like telescopes or binoculars. You can see it in the sky with yeah, it's in the Orion constellation just below Orion's belt. And so you can actually see like this kind of hazy like spot and in the sky, which is actually this nebula. And similarly to that, something you can also see in the sky is the Pleiades, or the Seven Sisters, as they're also commonly known, which are these, which it's a collection of very large and very hot blue supergiant stars who just happen to be in this gaseous nebula that's around them. And so their super bright blue glow illuminates the nebula in this way, and it just looks so pretty. And this is a special nebula. This is actually a supernova remnant. So unlike a planetary nebula, this is a nebula actually caused when a star does go supernova. And so when a star goes supernova, all of its outer layers explode, and so they can sometimes form these really pretty like sweeping arcs. And this arc here just so happens to be aligned with a star right there that looks quite cool. And so, also this star looks kind of like a cross because something else I have is a called a diffraction spike that basically puts like a cross over the front of your telescope lens, which causes light to diffract in such a way around small points of light, like a star, that causes this like you know 4 point thing. And there's an image of that later in the slideshow. But then something even more cool that you can take a picture of with this telescope is galaxies. Now, galaxies are full, like huge collections of stars and nebula, basically the biggest single body objects, well, not single body, but the biggest objects in the universe. Um, and so this big image here I will talk about a little bit later. Same with this one. But here, actually, this one here is the Triangulum galaxy, which is one of the closest galaxies to our galaxy, the Milky Way. It's in the local group. And this one's really pretty. It has some nice nebula colors in here. So like some of these like purple colors, red colors are actually nebula like in the last slide, but in a different galaxy. This one is really cool. This is the Whirlpool galaxy because it looks like a whirlpool. And it's actually two galaxies, this larger spiral galaxy and a smaller, I think, elliptical galaxy that are colliding and merging. Now, galaxies move on such huge time scales. They move so slowly that like we can't tell any difference. We can't actually see it moving. But we know that it is because of like gravity. Um, so this is a really cool galaxy, and it also has some cool color contrast between the purple of this galaxy and the yellow of that one. This is the Pinwheel galaxy, which is like a really pretty galaxy because it's a face-on spiral. It's a beautiful spiral galaxy that's facing us top down. So you can get really nice pictures of that one. And this up here is Bode's galaxy, and I guess it was discovered by some astronomer named Bode, but it's one of the brightest galaxies in the night sky and was quite a nice target to photograph. This little sliver here is aptly named the Sliver Galaxy, and as almost an opposite to this, it is facing, instead of face on, it's facing directly like edge on. This here is something really cool, which is a chain of galaxies. It's a group of galaxies all together called Markarian's chain. And so each of these different like things here is a galaxy. And this is another group of galaxies, but less distinct. There's one big one here, and then these two back here are not actually in a group with this one. They're they're like billions of light years behind it. Oops. But they just appear in the same place, which is a pretty cool, just natural coincidence. So this here is the Andromeda Galaxy. This is the Andromeda Galaxy, which is the closest galaxy to Earth. and it's about 2.5 times the size of the Milky Way, I believe, and has a couple companion galaxies. And so this is M110, I believe. They have designations of names for them as they're cataloged. And so this along with a lot of, I think, 110 other objects were cataloged by a very famous astronomer named Charles Messier. I don't know, like 100-ish years ago, maybe quite a while ago. So at the time, he was just marking them, excuse me, marking them as like interesting objects in the sky, not really knowing what they were. You know, most of them he thought were star clusters, and some of them are star clusters, but some of them, like this one, are galaxies. And so this one also is actually about 3 times the size of the full moon in the night sky. Like the full moon would fit 3 times horizontally across the screen. And this, I was able to take such a large image with a special feature called mosaic mode with the telescope, where basically it takes, if you imagine a large square that's bigger than the range that the telescope can take. It takes a photo in one part and moves to another part and then moves to another part and stacks all of those images together relative to each other to create a larger image that encompasses the whole object. So now we get into this. So the thing that makes these photos special, besides the long times of exposure, like for this one, I think it was like an hour and a half at least of exposure. But this isn't the image that comes directly out of the telescope. After I take the photo, this is what's given straight to me from the telescope, completely raw data. And so this data has to be processed through some software. And so yeah, so I think that's a cool comparison of like what it looks like originally and then the final image. And so I have that comparison with a few more of my favorites. Like, for example, this is the Orion Nebula before it was processed and after. And here's one more, the Triangulum Galaxy, before and after. Now, this one is a very stark difference. And also, it's a very stark difference that I can show you how the processing works to get from here to here. So, I'm actually gonna close this, and this desktop background is not a photo I've taken, by the way. So when I get the image from my telescope, it sends it to my iPad, and then I send that image to my computer. And then what I do is I will process it using 3 free softwares. The first of which is called Grapspert, and it will be in these softwares will be in a slide later. So this is Grapspert, and so it's a processing software for astronomical images. So I'm going to load the image. And so here is it just as the default shown. Now it actually stretches it a little bit because the photo that's taken actually doesn't even look like what I showed you before. This is the actual raw data. And this is linear mode, where it just shows it as a normal image, because if you imagine, it shows how the light was captured to the camera, because the way that humans see light is actually not like the scale of darkness to brightness is not a linear scale. It's curved. I think it's an exponential curve of how humans see light. And so in order to like process and allow the data to be seen as a normal person would be able to see it, you have to automatically stretch it a little bit. And so here is where we can actually start work. So if we zoom in, we can see this image is very grainy and noisy. So what we do to fix that, well, first, we're going to, we're going to denoise it. So this is the main thing that I use this program for, is denoising stuff and getting rid of the noise. So I'm going to do that. And so basically what it's doing is it's running an AI algorithm that is trained through many images and it like just goes through and kind of, I don't really know how it works, but it like equalizes the pixel values in some way to, make the noise go away. So this takes a second. And so after I use this software, then I will switch to the next one called Cyril, which is where the bulk of the work is done. And so I learned about these editing softwares also again through YouTube because after I got it and I discovered, oh, this is really cool, but I want to know how to I want to like take photos of galaxies or rather nebulas and stuff, and I saw these images online of like images people had taken with their sea stars, this telescope. And so on YouTube, I found this video of free softwares for processing images with the C Star. Because these three processing softwares are all free. But for comparison, the like main like professional like astrophotographer software is called PixInsight, which costs $200 to get, and then for like the extension called like Noise Exterminator that basically does this denoising thing costs like another 50 or 100, and then Blur Exterminator, which is another really good tool for planet processing, costs like another 50 or $100. And so like all that like mainstream stuff takes like it takes a lot of money. And so basically I'd be spending so much on processing software. And so this instead, these are all free apps that do quite a good job. And so here we see it's finished denoising. So this is now what I'm going to save this, the Triangulum Galaxy. I like to number my images so that I know which step I'm on. So download that. And now I'm going to quit this and move to the next program, Serial. So now I'm going to open this and I'm going to go to my downloads and open this. Now we again see it in linear mode. And so, but this has a nice function called auto stretch where it just automatically stretches it for you. Now, something that you can see here is that the top of this image is much more dark than the bottom of this image, which means we have something called a gradient in the background that can be caused by a number of things, either like a street light or the moon can actually cause this, which I think in this case it was probably the moon. So I'm going to do a thing called background extraction. So I'm going to change this grid tolerance to, I think, about 0.4 and generate a grid. And this will basically generate a grid of a bunch of places that it deems as the background of the image. And then once you're here, you can compute the background and it will like average the pixel values. And now we can see the image is much more symmetrical in its color grading. But now something else you can see is that it's very like yellow and doesn't really look very colorful. So something that you can do is color calibration. And so here it will compare the color of the stars in the image to stars of verified like color calibrated images in its database. So it's kind of an advanced process, but all I have to do is enter the name of this galaxy, its identifier, which is M33, part of the Messier catalog, and enter that, and then it will do it, and now it is calibrated the color. So now what I'm going to do, because it still looks like this as an actual photo. So then what I'm going to do, I'm going to kind of do two steps in one. I'm going to do star processing and star recomposition, or not star recomposition. I'm going to go to star processing and StarNet star removal. So StarNet is a tool that basically through an AI algorithm along with, I mean, I guess it is just an AI algorithm along with some stuff, removes all the stars from your image so you can just process the data of whatever you took a photo of. So I'm going to also click pre-stretch linear image so that instead of having to use a histogram and some curves, which I might still end up doing, it's going to automatically make the image more visible. So then I'm going to execute this. and it's going to take a second. And so normally if you didn't use this auto stretch function, you would use a histogram curve and modify the curve, which I can show in a second, because it stretches it, but usually you'll want to stretch it a little more in order to make it better.
Then when people take optical photos of astronomy objects, do they also process their images with this stuff?
So here now I have the histogram. So now right now it's very like the threshold for what I want is very small because this spike shows all of the color data in the image. So if I zoom in here, I can then edit this more, maybe. Oh, I'm gonna zoom back out because that didn't work. So I'm gonna put this here. I'm gonna apply, and now I'm gonna zoom in, and I can now adjust this, and that adjusts that. So then now here we can start to see the actual galaxy. And so here we're starting to see it, but also the background doesn't quite look black enough, and maybe I might want to do some color tweaks. So that's then where the next software comes in. And so now I'm going to save it. Now you'll notice that the name is Starless, as this program automatically does when it does star removal. And so now I'm saving it, and now I'm going to open it with the third program called GIMP. So now I'm going to open up this and open that. Here's right there. So here, I'm just going to select an option so that it reads the data correctly. And now here's GIMP, the final software. So now we can edit the curves more. GIMP has some very nice adjustments that you can do to curves, such as selecting a point, like where you want it, like, and it shows the like value of that color, how like bright it is in the image. And so then you can use this to darken the background very effectively. So I can darken the background a lot, but then I can also curve this and adjust the brightness of the galaxy itself. So now maybe I wanna make it brighter, but not too bright. So then here we have that. And then maybe I want to do a little bit of saturation to show the nebula color a little more. So I can turn up the saturation, and now we can really see the color of the nebulas in it. And this looks like quite a nice image of the galaxy. So now I'm going to export it and rename it and export. And now we're going to go back to the last program, Cyril, and we're going to recompose the stars. We're going to put the stars back in. So we're going to go to star processing and star recomposition. Now we're going to go to that one. And then now I'm going to turn up this a little bit to darken the background. And then I'm going to open this here, the star mask. And then I can stretch this up a bunch. And I'm going to just increase the black point slightly, slightly more, slightly more. So that we can, here, oh, it's the symmetry point is what I want. So this symmetry point changes basically where on the line you can see there where it cuts off the curve. So I'm going to just change this to about there. Nope, one more, there. So now we have a pretty nice balance of stars and the rest of the image. So maybe I'll turn up the black point a little bit to make the stars a little less bright. And so now we can apply this and close, and now is combined the images into this. And now I can just save this as Triangulum Galaxy Final and save it. And that will save the raw data of it because I saved it as a .fit. Then I can change the file format and save it as a .jpeg. And then we have our processed image. So yeah, that's how you process an image in this. So if we go back here, now we can see how we got from this to this. So this is the this is like all of the equipment and stuff I use. So this has the C star. And so this is a dew filter that I use. These are 3D printed things. And so this kind of goes over it and helps block and this helps block like extra light, like from if I'm putting it in our backyard, light from the kitchen, so that it doesn't like get into the image and create an unnecessary gradient. And then this is the star spike mask, which goes on top of that. And then you can, have spiked stars, which is cool for some images. And so then here, these are the three processing softwares. And so these are not, this processing, like this process of doing this processing is not just for the C star. You can use it for all sorts of astronomical images. Though something that I will note is that if you're taking photos from like, say, a traditional like big Dobsonian telescope or something, you will have to stack the images yourself using a separate software, which I know there's free softwares for that as well, which basically you have to stack. Remember how I said that there's like, it takes like 10-second or 20-second exposures and then stacks them together? And you have to use a program to do that instead of the C star just automatically doing it for you. But after that, you can just use these same things. And so the other thing that is used with the C star is an app on a mobile device, which is how you operate the thing. And so I think that gives a pretty good overview of the C star and how I do stuff. So uh, now I'm going to open it up for questions.
This is kind of a weird question, but you're so calm. Do you get excited when you start working on an image like that super pink one? Like, what was your reaction when you saw that? I'd be,
That super pink image, the Orion Nebula, I was very excited when I was doing that because that image was one of it was one of, I think it is either the or one of the best processing jobs I've ever done because like it's just so different from any other photo of it that I've been able to take or process, and it looks so different and so like good compared to its original image. Like there's stuff here in the original image that you can basically not see that are so vibrant in this image.
Mhm.
And like I feel like the processing on this image was just some of the best processing I've ever done. So yeah.
Fantastic. It's very fleshy.
Hmm.
It's really cool, Xander. I love
Thank
looking
you.
at that stuff. I
Thank
posted
you.
a picture of you at a car show in Fairfax some years back in the chat.
Hmm.
I really like that pic of you.
Hmm.
Xander, why, how do you avoid the light noise that we have just about? I don't know where you live or where you're shooting from, but is it pretty dark skies?
I mean, It's like, it's like kind of the outskirts of Fairfax, so not super dark, but I mean, you can see stuff. I could see, like, to see the Orion Nebula, you want like somewhat dark skies, but I could see it, like, I could see it myself without like a telescope or without binoculars. So, I mean, it's fairly dark. It's dark enough to take good images.
I have a question for you. How does that little machine, what kind of lens does it have that it's processed that?
Um, it has, I don't know the exact specifications of it, but hold on.
I was going to ask the same thing.
Because it's so small, it's almost
Yeah,
unbelievable.
it has what's called a oh yeah, yeah, yeah. So it has a triple well it has a triple apochromatic lens which
Mhm.
does like it controls, which is nice for astronomical photos because it controls chromatic aberration,
Mhm.
which it like makes like the stars stay like the round shape. But then it has I don't know. It has, hold on. Here it is. Okay, so the resolution is 1920 by 1080, and I don't know if the sensor is like anything special, but it's called an IMX 462. but the aperture is 50 millimeters, and the focal ratio is f5, and the focal length is 250 millimeters.
Okay. And how long are the exposures for?
Um, for the nebulas, they're usually like 30 minutes to an hour, and for the galaxies, I try to take at least an hour, if not longer, of exposure.
And then during that time, everything is moving. Does the little machine move with the star?
Yes, yes, it does.
Wow, that's
Um,
amazing.
yeah, it just like when you first start an exposure, it goes up and does a thing called I don't know, actually I don't know what it's called, but it looks at the part of the sky you're looking at and then goes a little bit to the right and a little bit to the
Mhm.
left to
Mhm.
determine its like how tilted it is on the ground as well. And then once it's completely calibrated itself with the sky, then it can just track the movement of the sky pretty
Mhm.
much perfectly.
And how much does that machine cost?
$500.
That's really cheap for
Yeah, yeah. That was one of the big selling points for me.
yeah, that's quite the whole thing is really remarkable because I do some astrophotography, but I do it with my camera and it's really complicated. But
Hmm.
that for $500, that's a trip, man. That's
Yeah.
amazing.
I
Yeah.
just looked it up. It's on B&H.
Yeah.
Hmm.
Yeah.
That
It's
Is it,
hour
very,
long
very cool.
that hour long exposure that you do, is that just one image or is that taking a bunch of images that you then stitch together later?
It's taking a bunch of images that I did, and it's actually stitching it together in real time. It takes 10-second exposures and then stacks them as it goes, which it shows in the app, which is really cool. So you can kind of get like a live feed of how your exposure is going and how it's looking, which is really nice when you're like taking long images to know if you've gotten long enough to see the thing or not.
Hmm.
Wow.
Very cool.
That's a fabulous description of the processing that goes on after you take the picture. You have
Thank
a
you.
you have a great understanding of the histogram and the use of curves. You know, that's a basic thing of photography. If you know that, you're there. Man, that's
Hmm.
the basic thing of photography is learning that stuff. And GIMP is a free thing. We forget that. It's been around for years, and it's just as good as Photoshop, really.
Hmm.
So, God, I'm glad it's still around. But I congratulate you for being proficient on this post-processing stuff, I guess you call it. It.
Hmm.
I've seen NASA photos like that. You know, that's I guess the same process they use. So it's amazing that it's free now, and you can get a telescope for $500. God, you know.
Yeah, it's amazing. Like photos like this, like a few years ago, to get photos like this, you would need a rig that cost like three, four, $5,000.
Yeah,
And
Mhm.
now you can just get it with that. And then that's not even including the price of like processing software. But
yeah.
now you can just do this for $500 and some free apps and you're good to go. It's really
Coordinated,
cool.
coordinated with your phone, even, you know, and
Hmm.
Do you miss a lot of sleep or do you get up do you stay up late or get up early or revolve your
Usually for
life
these
around the moon?
usually for these images, I try to find objects that are up when I'm like right before I go to bed so that, it doesn't completely ruin my sleep schedule.
Do
so
you do
what,
any other photography or do you do any?
I mean, I took a digital art and photography class last year, and so I did do a little bit of like photography normally, but I don't do that much now. Actually, something I do realize is that this telescope has another mode that's for like you can take like normal photos with it that are like super zoomed in of like nature photography and stuff, which is
Okay.
something cool.
Yeah. Yeah.
Have you printed any of these yet?
No, I haven't.
What are you aiming at when you're taking your shots at night? How does the camera do the focus for you, or what are you
Yeah, it
focusing?
does it pretty much like finds the object and focuses it all for me. I just have to pick the object and it already has a database on the app and knows where all the objects are. And
Oh
then you
wow,
just tell it to go to that and it finds it in the sky. It's really
that's
cool.
that's amazing.
That is,
Yeah.
Hmm.
that's
I have to interrupt for a second, Stephanie. I'm actually working. I'm working on some photographs that I need to deliver tonight. So
No worries.
thank you so much. I really enjoyed coming. And Xander, you're amazing. Your way of presenting is very, very professional. So thank you very much. I appreciate it.
Thank
Robert,
you.
join us for the show.
Okay, I will do that.
Get
Thank
the
you, guys.
PDF
Good night.
out of the chat, or I'll send it to you.
Xander, if you'd like to print something out for the show, you can come over and print something out at my house if you want, or probably there's other people here that have printers that would print something out too.
Hmm.
Oh, that's a nice offer.
Thank you for that. Yeah, thank you for that offer.
Yeah, yeah. All right. Well, thank you, Xander. I hope
Hmm.
you'll stay. Terry's going to do our second half. He doesn't need an introduction since he's been with us.
One last question for Xander.
Sure.
Hmm.
Anything you'd like to add that you might have left out that we should know about this stuff, or what's your favorite part of the sky?
Favorite part of the sky? Hmm. Well, actually, it's coming around really nicely right now. There's not like a part of the sky, but at this time of year, in the sky are a lot of galaxies, a lot of visible galaxies with this telescope, which are really nice to image. So I'm gonna be taking some nice images this summer. And then favorite part of the sky, probably like the Sagittarius constellation, because it's right near the core of the Milky Way, like right in that direction. So there's a bunch of really cool looking nebula all around there. So you can get some really nice photos.
Can that camera you're using, could you shoot something in Yosemite with a more enhanced view of the moon?
Um, wait,
Mhm.
sorry, I don't understand what you're asking. Say that again.
I guess if you were, let's just say you were in Yosemite and you were shooting Half Dome with this
Hmm.
another feature, would it enhance the moon as well? Like, would you have
I
a
mean, it'd basically be equivalent to using like a really big zoom lens, you know? Because like it's doing the same thing as a big zoom lens. So I mean, it would give you pretty much as much quality. I don't think it would really enhance it, especially over a zoom lens, because I don't know, but I think it would be pretty much about the same.
Hey,
okay?
Xander, what about shooting at altitude? Because down here, sea level, you have all the atmosphere to contend with. How are the images going to change, say, if you get up to 10 or 11,000 feet and you don't have to deal with all the atmosphere? Are the images going to be sharper or different?
Yeah, the images would be sharper, and they'd also probably they'd like be brighter. They'd have more data in them because more stuff can get through when there's less atmosphere. And so, yeah, they'd definitely be a lot sharper. Hmm.
Dennis?
Something for the future.
Question?
Yeah.
Dennis, go ahead.
Yes, thank you. Are you able to capture something like the Mir space station in flight?
You can, but I have not yet done so. It's something that's still on my bucket list. I need to find a time when the space station crosses in front of the sun or the moon so that I can take a really nice photo of it with that as a backdrop.
Mm-hmm.
Oh, that'd be great.
That would,
Would that catch it as a still photo or as a sequence?
I would be probably recording a raw video so that it records each frame as a still photo, and then I would be able to find the frames of it because I'd point it at the moon at the time that I know, or the sun that I know it's going to cross, and then be recording a raw video so that it saves each frame, and then I can pick out the frames that have the space station in it.
And what do you think the scale would be? Or could you adjust the scale?
I mean, the space station would be pretty small. It would be quite small, but I think you would be able to like make out, like the features of it, which I think would
Oh,
be pretty cool. Still
yeah,
need to do that.
you got to do that.
Hmm.
Yeah,
I think I have seen pictures of the space station with the backdrop of the moon.
Hmm.
They're fantastic. As I
Yeah.
remember. Yeah, if you could get that, that'd be priceless. Good God. That'd be
Before it falls down.
wow. So good luck with that.
Hmm.
Okay.
All right, everybody. Thank you so much, Xander. All
Thank you.
right. I'm
Of
gonna
course.
I'm gonna pass the torch now to Terry.
So what do I need to do?
I need to make you a co-host. Oops, I have to hit the right button. I have to hit participants. There it is. You're good to go.
I'm sorry, what do I hit?
Oh, share.
Here, okay. Let's see. Okay, so I'm going to talk through one of my favorite things to do is take street portraits. Can everybody see that photo?
Yes.
Good. Um, these shots that I'm going to show you, and it's very brief. I've got 4 or 5 that I'm going to walk through real quick. Shows some of the technique that I do, and these are all candid photos. They're, they're definitely not posed. They're quite often shot from the hip. Total street type work. And today, the software that's available has made it incredibly easy to clean these things up and do a lot of stuff to turn them into some really nice photos. So I'm going to show a little slideshow here. See if we can walk through this. So this one was taken in London about 10, 12 years ago. Let's see. So you can see down the bottom. I'm letting you know down below. You can read that. It tells you the camera I'm using and some of the settings and stuff like that. Over the course of time, I've moved to faster lenses, and I'm shooting a lot faster to get what I'm looking at. But so the first thing I do is I take the raw photo, like in this particular case. She had no idea that I was taking a photo of her. I then clean it up with Topaz. In this particular case, it was Topaz Sharpening AI versus the latest one, which is Photo AI. And you can see an amazing clarity done really with just one, just one minor adjustment on that Topaz. And then I drop in a background. And this is using Photoshop, um, an object selection and then an inverse and then moving over to generative fill. There's a couple of ways to do it, but this particular element with Photoshop's generative fill is amazing compared to some of the other methodologies that I've used in the past. So, I mean, I have hundreds of these type of series, and this has probably been some of the best um, uh, transitional of dropping background. I don't like to mess with the photo itself much, so I'm not going to change too much on it. I will sharpen it. This one needed sharpening. Most of the ones I'm going to show you do not need sharpening. They are just shot faster with faster lenses. The only negative on using generative fill is that if I wanted to use, I'm using a keyword here for generative fill, dark green fog background. You can't do it twice. You can't save that particular keyword. And if you want to go back and try to redo it again, you're going to have to go hit or miss to try to get to where you're going. So here's another one. I do a lot of these at protests, and even though I'm out there working, I'm actually recording the protests for the organizers, et cetera. But I'm always looking for an individual that as I was telling Dennis earlier in the thing, I like somebody that's got some facial hair and usually long hair and some interesting face. Doesn't need to be looking at me. This guy's sort of looking at me, but he's not. And again, I'm looks like I'm shooting upwards towards him, so it's probably shot from the hip. I do some sizing on it. In this particular case, it was just a crop of it, dropped in a fresh background. Now, the interesting thing, if you go through this, you'll see that there's some, when you do this generative fill, it will actually make some adjustments, AI type adjustments. It may change the hair a little bit. may change the hat size, and you're not going to really know. This one here doesn't really change, but there are. I noticed that there are some changes, so you got to be careful about it that it doesn't distort the photo itself. And then in this particular case, I kind of brightened up the face a little bit to my final. Here's another one taken just a couple of weeks ago, May Day. Um, just a it's a throwaway shot. I would never have used this in my protest work, but I liked the guy's look, and I liked his hair and everything about the person. And again, I'm not messing with his face or anything. I'm not changing anything there. I'm just letting the backdrop, and you can see that I've used the keyword dark cloudy skies. Again, I'll never get that twice. And that's the final. And here it is on the second go around. Same type of thing, dark cloudy skies, but look at two different skies. They're not the same. Um, and if you look at it closer, you probably will see there's a change in his hair. It's a little more bushed out. Um, I enjoy this type of work. Um, and here's another protest taken very recently. Um, this guy actually was looking at me, which wasn't my intent. It was still somewhat candid, but he had a nice face and a lot of stuff in the background that I didn't need, and I dropped it out with this generative fill and turn. I get a lot of play on these things when I post them on Facebook and stuff like that. I mean, it's just to me, it's fun. There's when you're doing street photography, you're always looking for that candid shot, that very interesting photo, and a face um, that's going to tell you something. And then the next series of photos are just a number of people that I've caught along the way. Almost all of these were taken at various protests, all of them completely candid, similar type of procedure. Some of them used generative fill, and some of them just used a background fill. Um, and occasionally I'll do a complete odd background, like I put this guy on a trail. Um, and this I was looking for something foggy. It was just an inch. I wanted to have something to kind of match this guy. This was taken in Sacramento. Um, Same thing with this guy here. And this was taken in Venice years ago. You can, if you look at the telephone or whatever he's holding, you can tell that it's a very old photo. And occasionally I'm just looking for something interesting, you know. I don't even know where I took this photo, but it was just an interesting shot. And this is from How Weird, San Francisco. A great place to do street photography. And then there's nothing better than a little grunge to mess up a photo. So all of these, like I said, are just plain out candid street shots, background dropped in. This is one of the earlier ones. It's not one of what I consider a very good one. The hair is a little messed up on the edges. Um, here's a more frequent one as well. Nice profile image. I just happen to like facial hair. Um, it it and I tend to like somebody's got a little bit of age on their face. So that's it. Any questions about techniques or whatever? I'm using a variety of software. The foundation of everything is always Photoshop, but I also use On1 Photomax. I use Topaz Photo AI. I pretty much replaced sharpening with that, the Topaz sharpening with Photo AI, which a much better software. Um, but generally speaking, most of these shots, because I'm shooting pretty fast, and you'll take a look at some of them down at the bottom, it kind of talks about some of the things. I mean, I'm shooting at generally at an ISO of 640 or more, always f2.8. So these are fast images, and that's why the later ones that I've done um, tend to not need a lot of processing, a lot of sharpening or clarity or anything like that. They're sharp right out the gate, just like that. And you know, you're taking these images on a moment's notice. I mean, you are just bang, flip the camera up and snap. It's just like that. Which is a lot of what protest shooting's all about anyway. I mean, you can't plan a shot. You're working at it, and along the way when I'm doing those work that photography, and I come back 2 hours later and I've shot 600 or 700 shots, and so there's always one or two in there that I think has got some promise to it. So that's it, folks. Any
Hey,
questions?
Terry, I'm impressed by the way it deals with hair. You got your the fill right behind it. I mean, there's
Yes, it does an excellent job with that. Now you might have to do a little bit of touch up on the selection but generally speaking, it drops it right behind it. There are a couple of different techniques to do. The generative fill I find is much better, but it is more of an AI than doing just a fill. And so you got to be careful what the AI is going to do because you don't want to distort the edges of the photo. But in this particular case, and I'm going to go back to this particular guy. Let's see if I can get to him. So
oh,
you can see that the hair on the left side of the image has
yeah,
changed a bit, but it's still got the black or the dark gray behind the image,
yeah,
you know,
yeah,
and if you look here, you know, that's not an easy thing to do. The AI in this particular case is probably telling itself that, oh, I can't do anything with that green back there. And
yeah,
so it's making some changes to it.
yeah,
And
yeah.
yet the other end, it's not that fuzzy either. I mean, you know,
It's
so if I
sharp.
bring it up, you know, you
That's
can see
sharp.
that it hasn't distorted it that much,
Yeah,
you know.
that's
Yeah.
yeah.
Is there a sense that you have of when you actually press the shutter?
You know what? In not necessarily. Now it's interesting, and anybody who does protest work, I mean, you'll see an image, you'll see a person that you want a photo of, and so you're talking about crowds of hundreds and maybe thousands of people. So you've got to get yourself in position to get that photo. I can't tell you that these photos are straight. Often they're not. You know, I'm shooting from the hip quite often. Um, you know, but you know, in this particular case, this is the only one where the guy actually looked straight at me. Now I don't know if he knew I was taking it at that time because I will quite often, well, actually, when I'm doing this kind of work, I'm not picking the camera up to my face.
Right. So
And
I guess I'm asking about your intuition when you're doing this.
it's it, it's a feel,
Yeah.
you know.
Okay.
That's all it is. It's a feel,
Right.
and you know, there are there's a in this particular case, I might have taken two images of him, and sometimes I'll take an image of someone and it won't be a good image, and I'll circle back around and say, okay, I want to get it again, but once again, I want it candid. I really prefer not to have a person looking at me, because there's a thing about in protest photography, photojournalism. If somebody's looking at you, they tend to smile.
Mhm.
And that is a no-no in our business. We don't want people smiling at us. We want a little bit of seriousness. This guy's actually got a little smile going on, you know. But typically speaking, you're looking for that other shot. These types of images don't actually make my photojournalism uploads because you know that you can't see the posters that they're carrying, and you really want to get in that type of work. You want to get your positioning as to what it's all about. Where are they at? You know, what kind of poster they're carrying or whatever. But here I'm just looking for a face, you know, and you know, for some reason, I just happen to like people with hair on their face. So you're not going to see too many women. I haven't found too many women with hair on their face, but you know,
Terry, there's a couple of those in there that look just like you.
I agree.
Yeah, there's well,
yeah,
there's a
there you
couple of
go.
others.
I could use a pair of glasses like that, but maybe if I grew a beard, I'd have it would match my mustache. Yeah,
Yeah,
yeah.
There was one guy I thought looked like you.
yeah, yeah, I haven't done it yet.
I have hundreds of
It's in
these
there
photos.
someplace.
Yeah. You know, it's a fun thing to do. I mean, you know what? I mean, it's just I'm not happy with a protest. And it's funny, I'm out there doing work for these organizations just like
Yep.
Stephanie and Peg and others that do this type of work. I mean, but to me, I'm not happy with my production unless I've got one or two of these photos. Because I'll go back home and I got to get this stuff done and up in the gallery that night. I mean, it's a rush. But then I'm looking for that one. Did I get myself a good photo that I can play with over the next few days? Anyway, that's it for me.
You, Terry.
I'll turn it back over to you.
Right.
Heck,
Well, I have
heck,
fixed the date on that flyer and I put it in the chat for next month. Is everybody feeling inspired? Can either go out and shoot faces or the face of the moon.
oh, that's two very good presentations tonight. Appreciate it.
Thank
Two
you.
different ones. I brought you back down to earth.
I have my head in the stars right now.
Yeah, me too.
All right. Well, I will see you all next month and let me know if you want to show some work. I hope everybody here will join us and do that.
Yeah,
And I
please.
think
We
everybody
can-
here knows that the festival's coming up in Fairfax on the 7th of June, and that's a great shooting gallery always.
Oh, yeah.
Is the way to get a hold of you, Stephanie, is just by emailing you?
Yes, and it's on that PDF. Did you grab it from the chat?
Yeah.
Great, great, great. I think we're good to go, everybody. I'm so glad you all came. Thank you, thank you.
Thank you.
Thanks,
Thank you,
everybody.
Stephanie.
Bye.
Thanks again, Xander, if you're still here.
I'm still here. You're welcome, and thank you.
You're
Yeah,
awesome.
that was great.
That's
Excellent show.
terrific presentation, folks.
Thank you.
Thank you.
And thank you,
Excellent.
Terry. Thank you so much for stepping up. And
Thanks, everybody.
all right. Good night. See
Good
y'all
night.
soon.
Bye.
Thank you.
Night.
Bye bye.